All right, guys, today we're going to be looking at our third FRQ. Once again, make sure you are not watching this video before you do the actual FRQ. Watch it after, give yourself a grade, submit it as normal. Okay, so we're looking at a function g of x, which is continuous, and we know that g of 2 is equal to 5. But then it tells us that this graph is the graph of g prime. So the first part, find the x-coordinate of all points of inflection. Well, we know a point of inflection is anywhere where the original function goes from or changes concavity, but we're working with the derivative, and that means it's where the derivative changes from increasing to decreasing or decreasing to increasing. So let's look back at this graph. We're looking for any places where it stops increasing and starts decreasing. Okay, got one right here. Or any places where it stops decreasing and starts increasing. Got one right there. So at, let's say, g prime changes from increasing to decreasing at, that's a t, not an at x equals 1, and g prime changes from decreasing to increasing. Ideally, you'll write the whole word, but I don't feel like writing that much. At x equals 4. So the points of inflection of g from -3, well, they give us just from -3 to 7, not less than or equal to. -3 to 7 are x equals 1 and x equals 4. Now this is going to be 2 points here. One for getting the correct x values and one for the whole explanation. Okay, let's move on to part B. Find the absolute maximum value of g on the interval from -3 to 7. Justify your answer. Now, absolute maximum means we have to consider two things: endpoints and critical points. Okay, our endpoints are easy. That's -3 and 7. Critical points are a little bit tougher because remember, we're looking at the graph of g. So we need to think, where are our critical points going to be? Well, critical points happen when the derivative is equal to 0. Well, that's going to be here and here. Okay, so that's at x equals -1 and x equals 2. So now we can consider all of these. We have x as -3, -1, 2, and 7. All of the x values we can consider. And then we're looking for the absolute maximum, which means we also need to know what the original function's value is. Now, here is the question. How do we set this up? Well, we know that to get g of x from g prime, we need the integral. But there's something else that was told to us that we're going to need. We're going to need our initial condition. Now, our initial condition is this right here. G of 2 is equal to 5. So we say g of 2 plus, and then because this is our initial condition at x equals 2, we have to go from 2 to x of g prime of t dt. Okay? Now, let's look at how that works in practice. So this is going to be g of 2, which is 5, plus the integral from 2 to -3 of g prime of x dx. Okay, so when we look at this, 5 is easy, but from 2 to -3, we're going to the left. So after we find the area, that means we're going to have to, I don't like how I drew that. After we find the area, that means we're going to have to multiply it by a negative, because we have to do the opposite sign since we are going to the left instead of to the right. So let's look at the area here. This first part right here, this is a triangle with an area with a height of 1 and a width of 1, 2, 3. So 3 times 1 times 1/2. That part right there is 3/2. Then over here we have another triangle with a width of 1, 2 and a height of -4. So -4 times -2, or not -2, -4 times 2, which gives us -8, and times 1/2 gives us -4. Okay, and then after we add these together, we're going to have to multiply by the opposite sign. So -4 plus 3/2, so this is -8/2, plus 3/2 gives us -5/2. Then times a negative gives us +5/2. All right, got that first area down. But then we have to add 5, so that gives us 15/2. Remember what we're looking for as we go through this. We're looking for the one that is the absolute maximum. All right, next we look at -1. Now, theoretically, we can look at this and say -1 should not be the absolute max. Why is that? Well, because it goes from negative to positive, which means this has to be a relative min. If it is a relative min, how can it be the absolute maximum point in the graph? It can't. But we're still going to do it anyway. So we have 5 plus the integral from 2 to -1, g prime of x dx. We already saw that from 2 to -1, that was 3/2. We found that area already. So it's -3/2, because we have to do the opposite sign because we're still going to the left, plus 5. So that gives us 7/2. It's definitely not going to be the max because that one's bigger. Moving on, I'm running out of space. Let me try and give myself a little bit more space here. We'll do 7 all the way at the bottom. All right, so for this one, we got 5 plus the integral from 2 to 2, g prime of x dx. Now this one should be easy to remember. Integral from 2 to 2 is 0, so that's just 5. And then lastly is 5 plus the integral from 2 to our, oh, I forgot 0. Look at me. That's why it looked a little weird. Forgot one at -6, or +6. Let's do that one first. 6. 5 plus the integral from 2 to 6 of g prime of x dx. That's 5 plus, from 2 to 6, that's just a triangle going underneath the graph. So 1, 2, 3, 4 with the 4. Height of -2, so that's -8 times 1/2 is -4. So plus -4, which equals 1. That's not the max. And then over here off to the side, because I'm running out of space, we'll do 7. So we have 5 plus the integral from 2 to 7 of g prime of x dx. We already know this was 1, or this was -4. So we just need this last little triangle here. That's a 1 by 1 triangle. So that's just 1/2 plus -4. So what's 1/2 plus -4? -8/2 plus 1, so -7/2. So this equals, that's 10/2 minus 7/2, 3/2. Okay. So 3/2, 1, 5, 7/2, 15/2. We're looking for the absolute maximum. So we get an absolute maximum value at 15 over 2. Absolute max at -3, 15 over 2. And there's our answer to B. This one has 3 points. 1 point just for making sure you consider x equals 2. 1 point for considering the endpoints. And then 1 point, so these both are 1 point. Not together each one, but in total, considering both endpoints is 1 point. And then 1 point for your maximum value and justification. Now, the justification part is this whole chart. If you did not do the whole chart, you did not get the absolute maximum with justification. You have to have the whole chart and the answer. If you didn't do it, you wouldn't get that last point. Okay? All right, moving on to part C. This is what I consider to be the easiest part, especially because we already got most of the information we need. We need the average rate of change of g of x. Well, the average rate of change of g of x is g of 7 minus g of -3 over 7 minus 3. That's the formula for average rate of change. And we just found on this past part that g of 7 was 3 over 2, and g of -3 was 15 over 2. And so then we just simplify. 3 minus 15, that gives us -12. -12 over 2 gives us -6, so -6 over 4, or in other words, -3 over 2. So that's the average rate of change. Pretty easy. 2 points here. 1 for setting up the average rate of change correctly, and 1 for the answer. All right, last part. Find the average rate of change of g prime of x on the integral from -3 to 7. So let's answer this part first. Average rate of change of g prime of x. So that would be g prime of 7 minus g prime of -3 over 7 minus -3. Oh, go back to that past problem. I just noticed. I forgot the -3. That should have been plus. This should have been 10. So this should have been -6 over 10 or -3 over 5. My bad, guys. All right, so 7 minus -3. We'll set this up to be 7, not 7, 1 minus -4 over 7 minus -3. 1 minus -4, that gives us 5. 7 minus -3, that gives us 10. So 1/2, pretty easy there. But that's not the whole part of the problem. Does the mean value theorem applied over the interval from -3 to 7 guarantee a value for c such that the second derivative is equal to the average rate of change? So all that's saying is, does the mean value theorem apply here? So we have to think, what does it mean for the mean value theorem to apply? The function has to be continuous and differentiable, and for it to apply, or for that to be the case, then that tells us that our average rate of change is equal to the exact rate of change. Well, we first need to check continuous and differentiable. So is g prime of x continuous at all points? Yes. The question is it differentiable at all points? And that is a resounding no, because of these sharp turns here. Remember, sharp turns make it not differentiable, which means our full answer would be no, the mean value theorem does not guarantee a value c where g double prime of c equals 1/2, because g prime of x is not differentiable at least, this isn't a great English sentence, but it works, at least 1 point for -3 to x to 7. So what this is saying is that mean value theorem does not guarantee a value c because g prime of x has at least one not differentiable point. And so this is 2 points. 1 point for getting the correct average value, or average rate of change, not average value, and then 1 point for the answer of no with reasoning. Okay, so 2 points here, 2 points here, 3 points, and 2 points. All right, make sure you get me, contact me if you have any questions. Let me know if there's anything you don't understand. Office hours and emails are all accepted.